Right, the next type of graph is the logistic or the sigmoid growth, and that's called the S. Now both of these graphs, the J and the S, is because of the shape. And this is the type of graph that we find that bigger animals with slower growth in the population size and with fewer numbers, but more stable populations will take this type of growth. Remember, we're busy with population studies, so it's important that you know this. Colin, we get different stages here as well.
Yes, and learners, you must know the different phases or stages here, but why this happens. Once again, it's the lag phase. And they can ask you why the growth is at such a slow rate here. Now, normally, organisms need to acclimatize here. They first need to find mates. They are maybe too young, they're not of a reproductive age yet, or they are very few in numbers. And then you can see as they settle in and they find their shelters, etc., then there's a positive acceleration phase, and all of a sudden there is a rapid increase, which is referred to as the exponential phase.
And up to there it's very much like a J curve, but then see what happens then.
Then you can see it goes off the number, the increase, it's decreasing all of a sudden. And the question is why, and you've heard the word environmental resistance. And when Lorraine said that environmental resistance is all of a sudden there are too many in this environment, the food becomes scarce, water becomes scarce, there are too many of them, and their excretion, it's toxins that's released. So there you can see, and all of a sudden there's a stationary phase where it flats down the curve.
Now that's an equilibrium. In other words, more may be born, but some die, so the numbers of the population stay more or less at the same time. Now, the number of that population, there where you get it, where it reaches the equilibrium phase, there, if we look at the number, that will be the carrying capacity. And we will refer to carrying capacity just now. So carrying capacity is the number of individuals that the environment can support, and it will be at that number where we reach equilibrium. So there's the phases that Colin has discussed with you.
Now, as we have spoken about this, so we're going to run through this quickly. There you can see the growth is slow because the population is small. They still have to look and find a mate to reproduce with, and they must still get used to the environment, which means they have to settle in, they have to build nests, etc., etc. Then we have the accelerating growth phase, also the exponential phase, and there it is at growth at its maximum, because many of them are sexually mature and they can reproduce. And then it will slow down. It's a decelerating phase where the growth rate decreases because of environmental resistance that sets in until the stable or equilibrium phase is reached. And this is where growth stops and the births are more equal to the death rate at that stage, and this is where the carrying capacity, and there you can see what is meant by carrying capacity. Know the definition of a carrying capacity is the maximum number of individuals of a species that an ecosystem can supply resources to. And I think, Lorraine, to explain to them what you mean by number.
Yeah, but just a moment, there you can see that this J curve is growing past the carrying capacity, which means that when it gets here, there won't be enough food, there won't be enough living space, and we might find a massive dying of individuals, so that we might have a total decimation of the population, or we might have to start all over again. And that's typical, as I've said, for something like insects. And there you can see that the S curve is much more stable. And there you've got your carrying capacity, which is a number around which the equilibrium will be reached, meaning that because of environmental resistance, this environment cannot support a bigger population.